Okay, let's look at section 2.3, problem number 62. All right, so the revenue function is given here, which is x times quantity 2000 minus 60. All right, so if you multiply out, you can see that you're going to get 60x squared plus 2000x, which is quadratic function. Right? So part A, sketch the graph of the revenue function, which is a quadratic function in a rectangular coordinate system, and x is going from 1 to 25. All right, so let's mark 1. So 1 is probably around here. And probably 25 is, I'll just put the 25 so that I can, it's not correct to scale, but it's say 25 is right there. Right? Then we know that this guy is a parabola, and this indicates that it's going to face down. Right? So you're going to have a face down parabola, looks kind of like this. Right? And also from this form, factored out form, x-intercept is going to be 0. So x-intercepts is going to be 0 is one of them. And the other one is set this equal to 0. So it's 2000 over 60, which is 100 over 3. So it's going to be about 3 points. So I'll just write 100 over 3, and which is about 33.3333. All right, so which is going to be over here. So I'll just mark that there. So it's 33. Actually, I should be precise. So let's say 100 over 3. How about that? All right, so this is going to be a parabola. So I'm going to just start from 0 and draw a parabola, and making sure that it goes through. Oh, so that's not good. And it goes through those two x-intercepts. All right. Then we know that here it has to start from 1, so it go up here. So start from this point and ends at, let's see, go straight up from 25, right? So the graph you can keep is starting from this point, and it's just a portion of the parabola, right? Oops. So that's, it doesn't look good, so I'll just rewrite that. So that's, right, that's the graph. Right, if you want, you can find the values here, but simply plugging in 1 into the revenue function, which is going to be 1 times 2000 minus 60 times 1. So it's going to give you 1,940. So here, so revenue is 1,940 in thousands of dollars. And the other point right here, we can find by plugging in 25 into that. So it's going to be a 25 times 2000 minus 60 times 25, right? Which is going to give you, let's see, it's a 25 times, right? So 60 times 25 is going to be 1,500. So 2,000 minus 1,500 would be 500. So 500, and that's going to give you, so it's going to be 1,125 with 2 zeros, right? So 12,500. So right here is 12,500. All right. All right, so this is the graph of y equals r of x. So this is a y equals r of x. All right, so that's part A. So and part B, find a value of that a value of x that will produce the maximum revenue. So we want to find the maximum revenue, but the maximum occurs right at the top, which is the vertex. So all you really have to do is find the vertex. So let's start with the r of x. So you have r of x is up here. So you can see that that's r of x. Right, so first step is factor out the negative 62. Right, then you're going to get x squared and minus 2,000 over 60x and parentheses. All right, so if I simplify that, this is going to be, let's see, 100 over 3 by dividing top and bottom by 20. All right, so we know that the third term we need is 1/2 of 100 over 3 squared would be 50 over 3 squared. So that's going to give you 2,500 over 3 squared. So it's going to be 9. But we have to subtract exactly the same one so that we don't change the function. So 2,500 over 9. All right. Then we can group these first 3 terms together to complete the square. So I'm going to just group them first. So you have negative 60. So you have x squared minus 100 over 3x and plus 2,500 over 9, right? Right, then you have this leftover term right here. So we're going to have to multiply by 60. So it's going to be minus, so it's going to be positive 60 times 2,500 over 9, right? Then we can rewrite it as, right, so negative 60 is still there. Right, then we can complete the square, so we can write it as x minus 50 over 3, because it's a 1/2 of 100 over 3 squared. So those are the 3 terms. Right, then I just have to simplify a little bit, so it's going to be, so now divide by 3, so 3 divide by 3, 20. So it's really 50,000. So 50. Not equal sign, sorry. So that's going to be a plus sign. So 50,000 over 3. So that's in vertex form. So the x value that will maximize the revenue would be sitting right here, 50 over 3. So answer to that. So x is going to be 50 over 3. Right? And the second part of part B is that, let's see, what is the maximum revenue? So maximum revenue would be this guy right here. So y coordinate of the vertex. All right, so 50,000 over 3 would be 16,667. So this is about, so approximately 16,667, right? So you can see that, so the maximum revenue, so maximum revenue would be 16,667. Right, remember that this is in thousand, so 1,000. So it's really $16,667,000. All right, so last part, part C. So what is the wholesale price per computer? So you can see that the price function is the first function right here, little p of x. So all you really have to do is plug in this x value into the p function. So this is going to be little p of 50 over 3. So which is going to be just 2,000 minus 60 times 50 over 3, right? So 3 cancels out and 220. So this is going to give you 2,000 minus 20 times 50 would be 1,000. So it's going to be, price is going to be $1,000 per computer. All right, that's it. I hope that this was clear.